Hello. In prior lessons, we learned about combining polynomials with addition, subtraction, and multiplication. In a sense, factoring polynomials is like the division operation with polynomials. We are looking for two or more polynomials that multiply together to equal another polynomial. There are several different ways to factor polynomials, but while considering those methods, we should be on the lookout for two special factoring techniques. One special technique is called factor by grouping, and another is factoring the sum or difference of cubes. For the factor by grouping technique, two criteria must be met. First, you must have a polynomial with 4 terms and no common factor. Also, the ratio of coefficients of the first and second term must be the same as the ratio of coefficients of the third and fourth. Let me show you some examples. In this first example, we see a 4-term polynomial with no common factors, so the first criterion has been met. For the second, we should check the ratio of coefficients. The first and second coefficients have a ratio of 1/3, and the third and fourth coefficients have a ratio of 4/12 that reduces to 1/3. So the second criterion has also been met. To complete the factor by grouping technique, we will group the first and second term together and factor the greatest common factor from each. We will do the same for the third and fourth term. There is now a binomial visible that is a common factor to the two remaining terms. If we factor this binomial from both terms, we would be left with the product of two binomials that represents the factored form of the original. Here's another example. After recognizing the 4 terms with no common factors, we should then check the ratios of the pairs of terms. Since the ratios are the same, we can finish factoring by grouping. Find the greatest common factor of each pair of terms. Then factor the binomial from each term that remains. And now we have the factored form of the original polynomial. I'd like you to try the last example on your own. However, the polynomial has a common factor across all 4 terms that must be factored first. Then the factor by grouping technique can be applied. Please pause the video now and resume playback in a moment to check your work. You might have noticed that there is a binomial that can be factored further. So the prime factorization of this polynomial looks like this. Now, another special technique used to factor polynomials is for the sum or difference of 2 cubes. This technique can be used when the original polynomial has 2 terms. Also, each term must be a perfect cube. The sum or difference of cubes will factor into the following patterns. In each case, a binomial will be multiplied by a prime trinomial. You'll notice that the patterns are very similar to one another, and after factoring is complete, you can check your work by multiplying the polynomials back together. The product will again be the original sum or difference of cubes. Let's take a look at a few examples. For this first problem, both terms are perfect cubes separated by an addition sign. So we have a sum of cubes. The cube root of x cubed is x, and the cube root of 64 is 4. By following the patterns shown above, we see the polynomial finish factoring like this. This result can and should be simplified. And to check our work, we can multiply them together to see if the result is the binomial with which we started. Try the next example on your own. Please pause the video now and resume playback in a moment to check your work. In the final example, we have a difference of cubes. The cube root of 125x cubed is 5x, and the cube root of 27 is 3. Using the pattern from above, we would have the factored result as follows. Be careful here since the results should be simplified, and we will see the following final answer. I hope these examples help you practice with factoring. Be on the lookout and use these methods to help simplify and reduce larger polynomials. Good luck.